Hello and welcome. Today we're taking a look at the source code for GNU Emacs. And I assume that most people who are watching this are familiar with Emacs, at least in the abstract. Emacs, I would say, is arguably one of the most important programs ever written, maybe the best program that's ever been written. I use it every day. I used it before even I started programming, and it's great. The thing that makes it great is it is basically just a Lisp machine, um, and as a Lisp machine, you can extend it arbitrarily, and so you can easily add a bunch of functionality. You can easily customize it. I don't customize my Emacs too much. There are some people who really go crazy. Have gone back and forth, kind of with trying to figure out what the optimal settings are. I found that the best bang for the buck is usually to stick relatively close to what the rest of the community is doing, so that the assumptions that they make about your workflow are somewhat realistic as they're developing their projects. But it's great. I've used a bunch of other editors. I've used extensively. I've used IntelliJ, which is really good for Java that I use it with, and IntelliJ has, um, in my experience, the best Emacs key bindings of any non-Emacs editor, which is nice. I've used VS Code, which has a lot of nice features, but isn't my favorite as a code editor. And I've used some, there's like an internal Google editor that a lot of people swore by. But I always went back to Emacs. Sometimes I go into another editor if there's some feature that I need. Like for one file, I might need auto completion to work better than I currently have it working in Emacs or something, and then I'll go visit another editor for like 20 minutes, and then I go back to Emacs because eventually I find that like I can't productively massage the code around in the way that I can with Emacs. So we'll take a look at it. I did want to mention one thing that I'm very excited about, which is that as of today, I have over 50 subscribers, which is amazing. And I wanted to thank everybody who subscribed or watched the videos. I really didn't expect that I would have so many subscribers so quickly for a show that is so, I guess, technical and maybe on the boring side. But I really appreciate all the love that people have shown, and that's made it easier to continue doing these videos. So thank you. And today I thought for fun I would check out. I would add ChatGPT to the list of things I'm up to. So let's see what ChatGPT's got to say. Let me maximize this here. All right, so let's ask ChatGPT who wrote Emacs. It's got to think. Take your time, ChatGPT. Okay, great. So ChatGPT says Richard Stallman wrote the original version of Emacs, which stands for Editor Macros, in the mid 1970s, while he was working at the Massachusetts Institute of Technology, also called MIT. Emacs was initially written in Tico, a text editor language for the DEC PDB-10 mainframe computer, and later rewritten in the C programming language. Stallman released the source code for Emacs under the terms of the GNU Public License, or GPL, which allows anyone to use, modify, and distribute the software as long as they also release the source code under the GPL. Today, Emacs is maintained and developed by a large community of contributors around the world. So, as you will often find, I think if you try to use ChatGPT, this is not right. So it's not horribly wrong, but we can actually look up who wrote the original Emacs. And it does go back to the 70s, but it's by David Moon and Guy Steele. I don't know as much about David Moon, but Guy Steele is a famous Lisp guy who was at MIT. And I think he wrote the famous Lisp book with, who is it, Sussman? Yeah, Gerald Sussman. Published more than 24 papers with Gerald Sussman on the subject of the language Lisp and its implementation, the Lambda papers. It's probably worth looking at the Lambda papers, and in fact, I will. Well, there's not much on them on Wikipedia. Okay, so it's written by Guy Steele and and David Moon, and then there were some other versions. There was like. I think there's a proprietary version by the guy that wrote that created the Java language, maybe in the 80s. And then Richard Stallman comes in the GNU project and creates a public version. And let's see if we can find when Stallman started writing his version of Emacs. Let's see. He was impressed by the Emacs while he returned to MIT. Stallman re-implemented this mode to run efficiently and added a macro feature to the Tico display system. Okay. Okay, so it sounds like Steele and Stallman did a bunch of work to improve it. I know that Stallman changed I think it's Gosling Emacs was the one before it that had some kind of Lispy thing, and Stallman replaced it with Emacs Lisp. And I don't have a sense of the first operational Emacs system existed in late 1976. Okay, so yeah, okay, so we have it goes back to the 70s, and a lot of the people involved in Emacs, we're also involved with Lisp machines. So let's just real quick see if we can find Lisp machine. Here's Emacs for Lisp machines in evolution of ein and zwei. And the original, let's see, early implementation, zwei, was written for the Lisp machine by Mike McCann and Daniel Weinreb. These were Emacs-like text editors. Okay. James Gosling, that's the Java guy, wrote Gosling Emacs in 1981. Okay, and then let's see when GNU Emacs comes out. Actually, this one says that Stallman wrote the first Emacs. This other guy says, let's see. This one says the original Emacs was written by Moon and Steele. And then the GNU article says Stallman wrote the first one in 1976. And then GNU Emacs begins in 1984. So I wonder if there's a legitimate priority dispute. So GNU Emacs was originally based on Gosling, but Stallman's replaced its mock Lisp interpreter with a true Lisp interpreter that required nearly all of its code to be rewritten. Okay, cool. All right, so what's at the root of this? What's at the root of this dispute? A set of editor macros for the Tico editor. So what does this say about Stallman? By the 1970s, TICO was already an old program, initially released in 1962. Richard Stallman visited the Stanford AI lab in 1976 and saw the lab's e-editor, written by Fred Wright. He was impressed by the editor's intuitive "what you see is what you get" behavior, which has since become the default behavior in most modern text editors. He returned to MIT, where Carl Mickelson, a hacker at the AI lab, had added to TICO a combined display editing mode called Control R that allowed the screen display to be updated each time the user entered a keystroke. Stallman re-implemented this mode to run efficiently and then added a macro feature to the TICO display editing mode that allowed the user to redefine any keystroke to run a TICO program. So maybe, actually, maybe I'm wrong. So maybe maybe this is referring to so this, it might be Wikipedia that's wrong. So let's look at these sources. What do we got? Emacs timeline. Yeah, so this one says Richard Stallman. Yeah, okay, so 1976, we get Tech Macro Real-Time Editors. That's Tech Mac and Tmax by Guy Steele. Yeah, so it sounds like Wikipedia was wrong, and I was wrong to tell ChatGPT that it was wrong. So maybe I should apologize to ChatGPT. So Richard Stallman, Guy Steele, and David Moon are credited with Emacs. Merger of TechMac and Tmax plus a dynamic loader and meta key commands. Okay. The author, I guess this is something by Stallman, became acquainted with Emacs, Stallman, on the ITS system at MIT. Okay. So I'll read this. What else we got? Emacs FAQ. The first Emacs was a set of macros written in 1976 at MIT by RMS. That's Richard Stallman for the editor TICO. Originally tape editor and corrector. Yeah, okay. So maximizing TICO, the original. It was Stallman. This is unreadable. Can I make this more readable? There we go. It was Stallman's innovations 2 years earlier, however, that marked the genesis of the editor we now know as Emacs. All right. So we start with TICO in 1976. Steele set about designing the key bindings for the new symmetrical command set and engaging Stallman in discussions about his idea. They began the implementation together, starting with no code, working intensely for the first line of development on the basic mechanism to look up and run commands. Leadership of the project then changed hands with Stallman as principal developer. Steele contributed little chunks of code in the days following. Resuming hacking with Stallman as a dyad. Okay. Richard Stallman is often credited as another co-creator, but as Daniel Weinreb wrote, the original TICO-based Emacs was created and designed by Guy Steele Jr. and David Moon. After they had it working, and it had become established as the standard text editor at the AI lab, Stallman took over its maintenance. Moon himself responded, "All true so far as I can remember. But in all fairness, I have to say that Stallman greatly improved Emacs after he liberated it from Guy and me." Yeah, okay. So a rebuttal to Stallman's story about the formation of Emacs and LMI. Yeah, okay. So I will bookmark this for reading later too. Richard Stallman has been telling a story about the origins of the Lisp machine companies and the effects on the MIT Artificial Intelligence Lab for many years. He has published it in a book and in a widely referenced paper, which you can find at this URL, rms-lisp.html. His account is highly biased and in many places just plain wrong. Here's my own perspective on what really happened. So I guess Greenblatt proposed a Lisp machine company that has two premises, blah, blah. Greenblatt would be the CEO. The other members of the Lisp Machine project were extremely dubious of Greenblatt's ability to run a company, so Greenblatt and the others went their separate ways and set up two companies. Stallman's characterization of this as backstabbing and that Symbolics decided not have scruples is pure hogwash. There is no backstabbing whatsoever. Stallman claims that Symbolics hired away all the hackers and that the AI lab was now helpless, and nobody had envisioned that the AI lab's hacker group would be wiped out, but it was, and that Symbolics wiped out MIT. First of all, there had been only one Lisp machine company, as Stallman would have preferred. Had there been only exactly the same people would have left the AI lab. Secondly, Symbolics only hired 4 full-time and 1 part-time person from the AI lab. Okay? So this is about, here we go. So, and while I'm setting the record straight, the original Tico-based Emacs was created and designed by Guy L. Steele Jr., and David Moon after they had it working and it had become established as the standard text editor at the AI lab. Stallman took over its maintenance. All right, so let's just grab this paragraph. And who's saying this? Dan Weinrab. I don't know who that is. I didn't mean for this to get so controversial so quickly. So Weinrab is a computer scientist, significant work on the environment programming language Lisp. He attended MIT, and he and Mike McCann wrote Ein and Zwei, which I guess were kind of predecessors to whatever the Emacs predecessor is, the Tech Max or whatever it was called. And that's the first Emacs written for a graphical user interface. Ein made use of the windowing system of the Lisp machine, and thus is the first Emacs written for a graphical user interface. Ein was the second implementation of Emacs ever written, and the first implementation of Emacs in Lisp. Most of the notable subsequent Emacs implementations use Lisp. Okay. So this is contentious, and maybe it's not ChatGPT's fault. All right, so I'll ask ChatGPT what it thinks. So I'll ask ChatGPT what it thinks that about the claim that David Moon and Guy Steele wrote the first Emacs. He's widely regarded as the original author. That's fair. That's true. It doesn't. I mean, it's true that he's widely regarded. That doesn't make it true that he is the original author. I think it's worth saying that like priority disputes like this are not especially interesting. Almost all inventions start with some other invention or innovation that came before it, right? And there's a lot of I don't know if you want to say copying, but a lot of at least conceptual copying, or like you start with somebody else's code. So I don't think it's worth digging too deep in. I'm just kind of curious to see what I can push ChatGPT to do. Let's see. So especially Steele, who played a significant role in rewriting Emacs in C and adding many features to the editor. However, Richard, has created the first version of the editor and released it as free software. It is worth noting that the development of Emacs has been a collaborative effort, with many people contributing to the code base. While Stallman may have been the initial creator of Emacs, the contribution of the others are okay. So let's see. I'm going to grab this claim from this paragraph from Daniel Weinreb's. So Dan Weinreb. Okay, it's widely accepted as true. All right. So in fact, Steele and Moon are credited with developing the first Emacs. Okay, you've reversed your position here, ChatGPT. All right, so ChatGPT is now telling me that Steele and Moon created the first Emacs at the MIT lab in the 70s prior to Richard Stallman's involvement with the project. Okay, so Stallman still played a role. So ChatGPT, at least lately, I don't think it used to do this, has done a lot, like it adds a lot of paragraphs that are kind of like um, hedging paragraphs or like summary paragraphs at the end. So while it's important to acknowledge the contributions, blah, blah, blah. Okay, thank you. Okay, so so given all this, would you say that Steele and Moon created first Emacs, or that Richard Stallman did? I don't know why ChatGPT is so slow on this VM. It's generally accepted that Steele and Moon created the first Emacs at MIT AI Lab. That's kind of like a repetition of what it said here. They developed the editor in Tico. Is this just a... It's not a literal restatement, and it became widely used and popular within. However, yeah, okay. All right. So I'm not the only one who's confused. We got ChatGPT to change its story. Often, if you get ChatGPT to change its story, it will apologize to you. But it's kind of doubling down on, it's reversed course, and it's not really drawing attention to it. Okay, thanks, ChatGPT. All right, I'll thank it. All right, great. Cool. All right, so that's Emacs. So it's got a long and storied history. So here's the actual code I have. So here's the actual code I have there. The GitHub mirror open. There's also this Savannah GNU thing. I don't think that's a link to their whatever you call it, the GitWeb thing. But I find it difficult to explore code in GitWeb. But I do have the Emacs source code open in Emacs in case I want to do anything fancier than just clicking a bunch of links. Okay, so let's look around in GitHub. We've got our README, which is good. So what do we expect to see? We expect it to be written in C, probably straight C and not C++. And we expect to see a Lisp implementation that is at the core. I don't know what I expect in terms of like what percentage of files are Lisp. Here we go. Emacs Lisp is 59.5%. ROF. I don't know what ROF is. Is that maybe a documentation thing? And then 15.7% C. We've got some Objective C, I guess, to make it run on iOS, Apple devices of various sorts. And we've got Common Lisp. Let's look up Common Lisp in ROF, and then Other in M4. M4 we looked up before. I forget exactly what it was. I guess let's figure out what M4 is. Oh yeah, it's a macro processor. Okay, so macro stuff. All right. Couldn't find any code. All right. It can't. Okay, but let's at least look at what ROF is so that I know what's going on. An early text formatter. ROF is a typewriter-oriented markup language. It is the first Unix text formatting computer program. Okay, it's the predecessor of nroff and troff. I've heard of troff before, but only as a thing that existed long ago that I've never had to deal with directly. So trough or in the 70s. I don't know when trough itself was released, but relatively old. So when was Roth made? We were also in the 70s. Okay. Cool. All right. So let's look at Emacs. So we've got, in terms of directory, we've got admin, build aux, which I'm going to guess is build scripty stuff, doc, etc. Lime. I don't know if that's important or not. Lib source, lib, lisp, lwlib, m4, modules, MS-DOS, MS-DOS, and next step are antiquated operating systems. Is next step an operating system or a windowing environment? I think it might just be a windowing environment. NT, I don't know, maybe Windows NT, old X menu, source, and test. So we're definitely going to look at source and test. We should look at lib. Sometimes people hide the real implementation in lib. And I guess let's just see what's in some of these directories that I don't recognize. Did I open lwlib? And let's look at these in reverse order, I guess. So lwlib as this, we got a readme. This subdirectory contains a Lucid widget library, which provides a uniform interface to a few different X toolkits. Okay, so that's windowing with X. I see programmer humor, devel.humor. This goes back, this is like programmer humor, maybe going back to the 70s. This could be a bit inappropriate, but I will glance at it. Somewhat against my better judgment. Spook.lines. Okay, so this directory contains the architecture-independent files used by or with Emacs. This includes some text files of documentation for GNU Emacs or of interest to Emacs users in the file of dumped doc strings for Emacs functions and variables. So this is etc. Architecture independent. That should be a lot of stuff, I would guess. So emacs.icon, emacs.desktop, edtuser.el, to do. That's read to do. Terms, problems, news. What's the oldest news? Let's look at news .1-17. Changelog.1. Copying SRE code. Tutorials, ref cards. Yeah, I'll look at a bunch of this stuff. Is org mode? I'm guessing it might be org mode. GNUs, I think, is the news reader. Forms, I don't know. We'll just, peek at a couple of these in reverse order. Okay, so car sets is just a README file for car set mapping files in this directory. Let's see. Formatting of mapping files. I don't know. Okay, it doesn't seem to be anything here. So let's get rid of it. E is eterm. Okay, terminfo source file, so some sort of terminal emulation. Forms. Some example files for the forms.el library. I don't know what forms.el is. Yeah, maybe this is it, forms mode. In Emacs major mode for working with simple textual databases in a forms-oriented manner. The information in these files is presented in Emacs window in a user-defined format, one record at a time. Okay, that seems mildly useful. Let's make sure we're quoting forms.el and see if we can get some images of what that looks like. I'm not convinced that any of these are forms. That's okay. All right. So something to do with form, like data presented in a nice way. Okay, here we are in org. The files org ODT content template and org ODT styles have the following copyright information: 2010 to 2023. These files are part of org mode's open document export module. Okay. So this is org mode stuff that exports to the open document format, I guess, which is like a word processing document format. All right. Ref cards. These are reference cards for GNU Emacs. Okay. So these are tech files. So it's like, I guess, a cheat sheet. So let's look at org mode or org card.tech. Lots of tech stuff. Align paragraphs. Instruct the sparse tree by typing this thing. Okay, so it's just key codes, and then they're rendered in various ways. Okay. Schema. What's in schema? Locate.rnc, relaxing.rnc, and schemas.xml are part of Emacs. They are used by nxml mode for mapping schemas to documents. The remaining files in this directory are schema for a variety of specifications released by the DocBook project. Okay, so this is XML stuff and DocBook stuff. I think, is DocBook XML? A semantic markup language. File name extension .xml. DocBook is an XML language. Okay. My SRE code. You can tell me what it is. Cert. Let's see. What is a cert file? I think it's c.sort. Is it sort? SRE code templates for C mode. Set mode, C mode. This looks like a program, right? So we're going to set the mode to C mode. We're going to set comment start to this. Is this like syntax highlighting stuff? Set comment prefix to that. Override this if your user or project template file in your user or project template file to whatever you might use for your project. So header extension is .h. So let's look up Emacs sort SRT files. So there's a subtitle thing, but I don't think that's what I'm looking at, right? What is this called? SRE code. SRE coder. SRE code is the semantic recoder, where semantic will parse source files into lists of tags. The semantic recoder will aid in converting semantic tags to various other information and back into various types of code. So it does look like it's syntax highlighty stuff. A template manager and code generator that is part of cedit. It's designed to be used in applications that need to generate code. Okay, it's for code generation. So cedit is a collection of tools written with the end goal of creating an advanced development environment. Okay. Main components of cedit are speedbar, Emacs Lisp objects, EIEIO, semantic bovinator, semantic recoder. Okay, so this is cedit stuff. I'm not sure what the status of something like cedit is now. A lot of, for IDE-like features, Microsoft has open sourced some standards like LSP, the language server protocol, and a debugger protocol, which might be DAP. I'm not positive I'm remembering that correctly. So these are things, I don't know if Microsoft had developed these for like the closed source version of Visual Studio, but they're part of, I think they were released in conjunction with their open sourcing of a version of Visual Studio. So those have kind of taken over because they're, well designed and easy to support, and they're supportable across different platforms, whereas something like cedit, I guess, is Emacs specific. Okay, so here we are in News 1-17, copyright 1985 to 86, and then some stuff later. This file is about changes in Emacs versions 1 through 17. All right, MX Doctor. MX Hanoi. Oh, is that like Tower of Hanoi? Try Yao. Did I try Yao? I guess let's try Yao. Is this still a thing? All right. Let's find out what Yao did. Quote random Zippyisms. I guess these are quotes from Zippy. Right? I assume the Zippyisms are like part of here. Okay. All right. Let's see. The Tahoe, Sun 3, Sequent, and Celerity use 4.2. In regard to the Apollo, okay, some old machines. Do we have any dates? We have normal mode, Duret improvements. Okay. Cool. Problems. This file describes various problems that have been encountered in compiling, installing, and running Emacs, or in running GNU Emacs. Try doing CCT and browsing through the outline headers. Mule UCS doesn't work on Emacs 23 onwards. Emacs startup failures. Some X stuff. Okay, these are like tips for fixing stuff. I'm not sure, when was this file last updated? History, maybe? (2023). Okay. Describe problems with Mu PDF 1.21. And this was when? On January 14th. Does that mean, I guess, January 14th of this year? I guess so. Okay. So that's problems that you might encounter, like compiling Emacs or whatever. Terms. This file describes what you must or might want to do in term cap entries to make terminals work properly and efficiently with Emacs. Okay, nice for usability, considerably more than 24 lines. Meta key, a shift-like key that controls the 0 to 100 bit in every character you type. Nice for speed, supports insert, delete of multiple lines in one command. Same for multiple characters. Vital, easy to compute suitable padding for never ever sends, I'm not sure how to pronounce this, but up caret S or up caret Q, unless you type them, at least in one mode. Okay. So a bunch of terminal stuff. That seems useful if you're making Emacs work in a new terminal. All right, here's the to-do list going back to, I guess, 2001 to 2023. High priority items, things related to ELPA, which is, I guess, a package repository. We need to figure out how to best include GNU ELPA packages in the Emacs tarball before doing any of the items below. You can move idle wave to ELPA, move org mode to ELPA. Okay. So I guess they want to unbundle some of the stuff that's in the Emacs code base and move it to ELPA, and then I guess rebundle it at packaging time. Fix the kill-yang treatment of invisible text. At the moment, invisible text is placed in the kill ring so that the contents of the ring may not correspond to the text as displayed to the user. It ought to be possible to omit text which is invisible due to a text property, overlay, or selected display from the kill ring. Yeah, that would be useful. Emacs as word processor. RMS writes, 25 years ago, I hoped we would extend Emacs to do what you see is what you get word processing. That is why we added text properties and variable width fonts. However, more features are still needed to achieve this. This is from 10 years ago. I guess specifically a major mode with the following features and abilities should be added to Emacs. Import and export Office documents. Import and export open document format. Export. The existing enriched mode can be used as a starting point. Okay. That seems pretty reasonable, actually. Pixel level text fill justification and indentation so that the variable pitch fonts can be freely used. Yeah, that's a lot of work, but that would be pretty cool to be able to edit Word-like documents instead of, I guess, using Google Docs or Microsoft Word or LibreOffice or whatever people use. All right, what is spook.lines? Um, is this supposed to be like stuff that will get you put on a list? There's stuff about gold bullion, scammers, skiff. Huh. What is spook? MX spook. MX spook adds a line of randomly chosen keywords to an outgoing mailman. Okay. All right. I'm not sure that seems well advised, but there you go. The free, okay, so jokes. Richard Stallman is writing a Unix clone called GNU, which means GNU's not Unix, a recursive acronym. What year is this? We get a year? I don't get a year. What do you use a supercomputer for? Numerical analysis. Okay. Oh, wait, maybe the year is 1990. I saw 1991 below in the message ID, I guess. Okay. Just some goofiness. I'm not going to read too much. All right. Develop humor. Humor, sometimes unintended, on the Emacs developers list. This is like a quotes, funny quotes from the Emacs developer mailing list, and they committed them to source code. I remember those versions as yard rocks. Is that between inch pebbles and milestones? Okay. All right. Cool. And that's etc. All right. So that's etc. What does Lime do? Let's see. Contains Lime. Lime stands for Libraries of Emacs Input Methods. So this directory contains source dictionaries, TIT format for Chinese input method, distributed with CX term. These dictionaries are automatically converted to Quail packages, Emacs Lisp source files by make. Okay, some language input stuff. Lib source. This directory contains the source code for the architecture dependent files that go in archlibdir. At present, they are mostly utility programs used by Emacs. So this is architecture dependent. So stuff to make it work with various types of machine. Here's lib. All right, warn on use. So these are C files. These are not Lisp files. I guess I'll look at warn on use. I'm just picking a few victims here because I'm not really sure what's going to be super important. STP copy standard lib in.h. Yeah, sure. Sturt toll. I guess so. Some SHA cryptographic algorithms. Set permissions. Scratch buffer.h. Yeah, I'll look at scratch buffer.h. regex. Half max. nproc. I make timestamp limits. Int props. Ignore value. IEEE 754. I don't know what that is. GNU lib. Get time of day. Get time. You see, a lot of these sound like they're like system calls. fstatat. Free. File name. And maybe they are. Durant. Copy file range. cdefs. Care add link at. C++ defs. Let's look at C++ defs. Allocator. Sure, let's look at the allocator. And let's look at ACL and ACL entries. Just to get a sense of what's in here. Return the number of entries in an ACL. All right. Now we've got ACL entries. This is kind of a strange style of C. the return value is above the rest of the function definition, and then parentheses are left justified. We're going to initialize count to 0. If the ACL is not null, we're going to do some stuff. Is this aligned properly? I guess it is. Okay. If ACL has first entry, and then there's a space after this if, and I don't know if that's intentional. Maybe it's a typo, or maybe this one's a typo. If ACL type extended, then ACL entry T ace int got1 for got1 equals ACL entry. We're going to increment the count. That's kind of disorienting to read. Else we'll do some stuff. And if, else, if. Okay, so, all right. This file assumes POSIX draft like ACLs. So are ACLs part of POSIX? I guess they must be. Is that the same as file permissions? ACL. Access control list. This manual page describes POSIX, access control lists, which are used to define more fine-grained discretionary access rights for files and directory. Do I have ACL installed? Can I install it? Something NFS related. POSIX 1E ACLs. Python pylib though. Okay. I guess I can't. All right. So whatever ACLs are, there's some POSIX thing for finer grained permissions for access control lists. Right. Allocator. What does their allocator do? It's written by Paul Eggert. Memory allocators such as malloc and free, right? Do not use GCC attributes such as underscore attribute malloc with the function types pointed at by these members because these attributes do not work with pointers to functions. See this mailing list thing. So call allocate to allocate memory like malloc. On failure, allocate should return null, though not necessarily set errno. When given 0 size, it may return null even if successful. You can call free. I wonder why they need their own allocators. So let's look at allocator.c. See if it gives us any explanation. We're going to include allocator.h and struct allocator const standard lib allocator to be malloc, realloc, free, and null. Is it just setting the allocators to use the standard lib ones? An allocator using the standard lib functions and a null die function. Okay, yeah, it's just using the standard ones. I don't know if they use different ones at another point. Let's see. Merge from GNU lib. Yeah, okay. It seems like they've been using standard allocators for a long time. All right, C++ defs. We're in the GNU lib namespace. I guess GNU lib, is that the standard library? Also called the GNU Portability Library, is a collection of software subroutines that are designed to be usable on many operating systems. So it's like a portability library. Not to be confused with glibc, the GNU implementation of the C standard library, or glib. Yeah, okay. All right, so I don't know what the relationship with is with GNU lib, but I guess Emacs is, maybe these are shared with GNU lib. Maybe it's basically like vendoring the GNU lib libraries in the Emacs repo. The three most frequent use cases of these macros are for providing a substitute for a function that is missing on some platforms, but is declared and works fine on the platforms on which it exists. Like if GNU lib foo at, if not have foo at, gl func decal sys foo blah blah blah, and if, and then we've got gl cxx alias and some alias warn for providing a replacement for a function that exists on all platforms, but is broken or insufficient and needs to be replaced on some platforms. Okay, so this is portability stuff. So you can define, like redefine stuff using like macros so that everything compiles and runs on the various platforms. Okay, what is pathmax? POSIX 2008 defines pathmax to be the maximum number of bytes in a file name, including the terminating null byte. Okay. All right, so this is stuff about path sizes. Here's regex. It'll allow the use in C++ code. Define, use GNU to declare GNU extensions that violate the POSIX namespace rules. Okay. Yeah, so this is just regular expression stuff. I guess I was curious if it would say anything about this being modified for use in Emacs, but this looks not super Emacs specific. Here's an Emacs variable. Regular expression syntax Emacs, I guess. Define combination of the above bits for the standard possibilities. The triple bracket comments to limit what gets put in the tech info file, so don't delete them. All right. RE syntax grep is going to be, I guess this is like a combination of these syntax thingies. It's either an RE syntax POSIX basic, maybe, or a new line alt. Maybe, I don't know. Let's see if there are many other occurrences of the word Emacs in this file. Oh, we get 6 matches. So that's not a lot. Okay. All right. So that's just some regular expression library stuff. It seems like Emacs/lib is not super Emacs specific in general. It's mostly like basic GNU stuff that's used by Emacs. Although we do have scratch buffers with a default stack allocation and fallback to heap allocation. It is expected that this function is used in this way: struct scratch buffer temp buffer, scratch buffer init temp buffer. While function that uses buffer returns, we're going to not the function, right? So while it returns, while it's continuing to return true, no, while it's continuing to return false, if scratch buffer grow returns false, we'll return -1. Scratch buffer free, the temp buffer, and return 0. The allocation functions scratch buffer go, scratch buffer grow reserve, and scratch buffer set array size make sure that the heap allocation, if any, is freed, so that the code above does not have a memory leak. The buffer still remains in a state that can be deallocated using scratch buffer free, so a loop like this is valid as well, and it just has another loop. Okay, so that's scratch buffer, and we can grow it. What is stirtol? I don't know. sh lib compat, libc shared, libc shared. Something about weak alias, compat symbol. Maybe stirtol is a system call. Stirtol, C++, parses the C string stir, interpreting its content as an integral number of the specific base. Okay. Which is returned as a value of type long. All right. So it's, I guess, string to long. Warn on use. GL warn on use function, literal string, issues a declaration for function which will then trigger a compiler warning containing the text of literal string anywhere the function is called. All right, so this is just making functions warn if you use them, I guess, for deprecation. What does it say? I think I saw the word poisoned. However, one of the reasons that a function is a portability trap is if it has the wrong signature. Okay, so this is for preventing you from making known mistakes when writing portable code. All right, so that is lib. There's not a lot going on in lib that seems super Emacs-y. It seems mostly C and C++-y as used by the Emacs people. So here's Emacs/Lisp. I guess before we get to Lisp, let's do source and test. So test, a fair number of tests. This directory contains files intended to test various aspects of Emacs functionality. Please help add tests. See the fileorganization.org for the details of the directory structure and file naming conventions. All right, so let's just pick a victim, source, I guess. Alloc tests, yeah, sure. So we're going to require ERT, which is maybe a testing framework, and CLib, and we're going to ERT def test finalizer object type should equal type of make finalizer, ignore finalizer. Okay, these tests are readable. ERT def test record 3, let star x record foo 123, y copy sequence x should not equal xy, do times I4 should equal aref xi, aref yi. So these things should be equal after we copy them. Okay, cool. Test seems pretty good. All right, here's source. Got bitmaps, which I'm going to ignore. We've got an allocator again, a timer, BD, which might be bidirectional. Block input block. We should look at buffer and buffer.c, hoping those are Emacs buffers. Case tab, case fiddle, call proc. I guess we'll ignore call proc. I guess we'll look at category. Character set, commands. Coding.c. Let's look at coding.c. Let's look at commands.h. Composite, data, dbus bind. I guess that's not it. And by the way, these are all C and in C header files. This is not Lisp yet. Okay, we've got doc, edit functions, Emacs icon. Let's look at edit functions. File IO eval, you should look at eval.c. Frame. Look at both frame.h and frame.c. I think I just opened frame.h twice, but I'll fix that later. We got GNU TLS, which is like a competitor TLS implementation to OpenSSL. Haiku draw support, Haiku font support. I think Haiku is an old operating system. There's a lot of Haiku stuff. Image indent. Let's look at indent. I notify intervals iTree. Yeah, look at iTree. JSON, keyboard, key map. Let's look at key map. LRead Mac font, some Mac stuff. I guess probably the Mac OS. Menu. I'll look at menu. MS-DOS. NSFNS. I don't know what that is. NSGUI. Maybe next step. Some PGT stuff. I don't know what PGT is. Process.h. I will look at profile. I guess I'll look at process.h. ralloc roll scroll. I'll look at search. SHEAP. Sort, sound, syntax. I'll look at syntax. Syssignal, systhread, term. Look at term. And terminal. Threads. Tree sitter. I'll look quickly at tree sitter. Bunch of W32, which is maybe Windows 32. X faces. I'll ignore, I guess, for now. X menu, XML, X settings, X widget. So this directory contains the source files for the C component of GNU Emacs. Nothing in this directory is needed for using Emacs once it is built and installed, if the dumped Emacs is copied elsewhere. Okay. All right, alloc.c. Okay, so we're importing a bunch of stuff, including pthread, if we have pthread. Error no, limit, signal, kind of standard low-level C stuff, buffer, window, keyboard, frame, block input. Why does the alloc need to know about tree sitter and buffer and term hooks and frames? I don't know. So we've got address sanitizer, which exposes additional functions for manually marking memory as poisoned or unpoisoned. So this is ASAN support, address sanitizer support, a bunch of if defs, Emacs align type, a type with alignment at least as large as any object that Emacs allocates. This is not max align T because some platforms, for example, MinGW, have buggy malloc implementations that do not align for max align T. Okay, we've got some max area, specify maximum number of areas to mmap. It would be nice to use a value that explicitly means no limit. Malloc initialize hook, restore the dumped malloc state. So we can dump the malloc state. Because malloc can be invoked even before main, e.g. by the dynamic linker, the dumped malloc state must be restored as early as possible using this special hook. Okay. I don't know why you dump malloc state. Here's a malloc initialization hook. We can mark, unmark, and query mark bit of a Lisp string. Okay. During garbage collection, GC in progress is true. We've got a pointer to spare memory to be free to be run out of memory. I guess this is like garbage collection stuff, but it seems a bit hacky. I don't know if this is like a generational garbage collector. It seems like it's like pointing to a list of things that we might free if we can. Max save stack, unchained finalizer, mark terminals, GC sweep, mark buffer. Yeah, so this is garbage collection stuff. So we can sweep the garbage collection. We can mark a buffer. I don't know what marking a buffer but maybe it means we mark it as able to be collected, ready to be possibly collected. And scanning the C stack for live Lisp objects. Emacs keeps track of what memory allocated via Lisp malloc and Lisp align malloc is intended for what purpose. This enumeration specifies the type of memory. Okay. So when we alloc, maybe this is why they need their own allocator. So when they allocate, they keep track somehow of this enum, which they use for garbage collection. So non-Lisp, whether it's a cons, a string, a symbol, a float, whether it's vector-like, whether it's a vector block, and whether it's spare or reserved memory. And then we have a GC malloc check thing, a node. Okay, so a node in the red-black tree describing allocated memory containing Lisp data. Each such block is recorded with its start and end address when it is allocated, and removed from the tree when it is free. A red-black tree is a balanced binary tree with the following properties. So here we are again with the self-balancing binary trees. I think it's self-balancing. We'll have to look it up. Every node is either red or black. Every leaf is black. If a node is red, then both of its children are black. Every simple path from a node to a descendant leaf contains the same number of black nodes. The root is always black. When nodes are inserted into the tree or deleted from the tree is fixed so that the properties are always true. Yeah, okay, so it's self-balancing. Why use red-black instead of AVL? I don't know, but it seems like Emacs uses red-black for garbage collection, and gRPC uses AVL for, I forget exactly what they were doing with the tree, maybe with, I don't know if that was part of their priority system or what, but is part of whatever gRPC was doing. Okay, so yeah, so this is I guess mainly a bunch of stuff that's needed for garbage collection. So I'm going to think about. So yeah, so BiDi is bidirectional buffer string scanning functions for GNU Emacs. I'm not going to really look at them. You can fetch the next character, resolve weak types, some paired bracket stuff. Each level calls, actually, this is pretty interesting. Each level calls a level below it and works on the result returned by the lower level, including all of its sublevels. In a nutshell, fetching the next character boils down to calling string char length and passing it to the address of a buffer in or string position. Yeah, this is a huge comment. We'll at least scroll through this to see it in all of its grandeur. Caching the this seems like this must be. My guess is that given the level of code commenting and given how many lines of code there are, that if you really wanted to understand Emacs internals, that you would need to understand this file. But I don't think we're there yet. We're more just exploring what's going on. Okay, so here we are in buffer.h. Accessing the parameters of the current buffer. These constants and macros come in pairs, one for the char position and one for the byte position. We can position the position of beginning of accessible range of buffer. Okay. Beg v, I guess, is the I don't know what v stands for, but underscore byte, I guess, is the byte version. So pt byte, gpt byte. Position of gap in buffer is gpt. End is zv. Right, then we have macros for the addresses of places in the buffer. So beginning of buffer, beginning of accessible range, address of point in the buffer, which is a pt adder and takes a byte position address and a current buffer to point byte. Okay. Modification count. The character modification count, overlay, modification count. Okay. Lots of macros. Functions to set pt, I guess this is point, right? Setting point in the current buffer or another buffer. Extern set point, yep. And we've got a pointer diff t. I don't know why it's a diff. I guess you pass in the diff between where you are and where you want it to be. Temp set point both. And then we've got some inline functions. And set point at pointer diff t position is going to call set point at position. We can temporarily set point. We can set point both. So okay. Then we've got maximum number of bytes in a buffer. Buffer cannot contain more bytes than a one origin fixed num can represent. Right? I'm just curious. You can find more about diff. What was it called? PT diff? Pointer diff. Set point. Extern void set point pointer diff t. What is the extern? Characters, Lisp t? Lisp itree? I'm not sure. Maybe maybe Emacs will help me. Let's search in not in general. Let's search in source. Okay. So we're calling extern static void, blah, blah, blah. Is it in buffer? That's C. Is pointer D is not pointer diff is not a system thing, is it? Static pointer T diff. That's a return value. All right. I'm not sure. I don't think there's a file called pointer. So let's maybe just do a search. Oh, it is a standard CPP thing. Pointer diff is used for pointer arithmetic and array indexing if negative values are possible. Okay. It's the signed integer type of the result of subtracting two pointers. Okay. So there's a difference between two pointers. And that's what we're going to use to set where things go in the buffer. Okay. Cool. So we've got a struct buffer, and let's see what it has. It's got a name, a file name, a directory, whether it's been backed up, save length, which is the length of the file when last read or saved, whether it's read only, whether it has if it has an autosave file name, mark, the mark. This is a marker which may point into this buffer or may point nowhere. So that's mark. It's a Lisp object. These are all Lisp object types. Local var a list, major mode, minor mode, mode name, mode line format, header line format, tab line format, so you can change all the formats, a key map, an abbreviation table, syntax table, category table, case fold search, tab width, fill column, left margin. These are values of several buffer local variables. Tab width is buffer local so that redisplay can find it in buffers that are not current. Okay. An autofill function, which you call when insert space past fill column. Down case table, up case table for case conversions. Okay. Case canon table. Car table for conversion to case folding search. I'm not sure what that is. That's the first thing that I'm not positive that I recognize. Car table of equivalences for case folding search. Whether or not to truncate lines, whether to wrap words. Control arrow. Non-nil means display control characters with up arrow. And a bunch of other stuff. I can't read them all. Fringes, outside margins. So a mix of like display stuff and also things like where the mark is and what is, fonts and just anything that you can really customize as part of a buffer, I guess. If you have tree sitter, then you can have a Lisp object TS parser list as part of your buffer. Okay. Last window start. Yeah, just buffery things. So this is where buffer stuff lives. Cool. And then buffer.c, I'm not going to look at because we have a sense of what's going on here from the header. Category.h, I'm just curious what this might be. We introduce here three types of object: category, category set, and category table. A category is like syntax, but differs in the following points. A category is represented by a mnemonic character in the range 32 to 126, that is printable ASCII characters. A category is not exclusive, that is, a character has multiple categories, category set. Okay, in addition to predefined categories, a user can define new categories. What did they say it was like? It was like syntax. A category table is like syntax table, represented by a Lisp card table. The elements of the category sets are nil. Yeah, what is it used for? Return the version number of the category table. Word boundary. Car has category. Make category set. I don't know. It sounds like it might be kind of like a type. Let's see if the C file has any info. Make category set. Return a newly created category set with categories. I don't know. Let's see Emacs category. Categories. Provide an alternate way of classifying characters syntactically. You can define several categories as needed and independently assign each character to one or more categories. Unlike syntax classes, categories are not mutually exclusive. Okay, so is this for display stuff mainly? All right. That's, I think, something else. Okay. All right, whatever it is, I think it's maybe it's like syntax, but more flexible than syntax. So I'm guessing it's used mainly for display, or possibly also for anything that needs to understand the code, like if you're lexing or parsing or something. Okay, here we are in coding.h. I'm not sure what we're coding. We can define coding system argindex. We've got name, mnemonic, coding type, car set, list, encode translation table. This seems like font and syntaxy stuff. Docstring, base name, type, ASCII compat. Keys are coding system symbols and values are spec vectors of the corresponding coding system. Macros to access an element of an attribute vector. Okay. Yeah. Okay. I don't know. I'm guessing that this is something to do with like fonts or character encoding or something texty. All right. We've got a table of contents comment, preamble. Oh man. Okay, yeah, UTF-8, UTF-16. These are like character encodings. Okay. All right, commands.h. We've got control and unread switch frame interactive. If not Q nil, this is a switch frame event which we decided to put off until the end of a key sequence. So we've defined the control key and no C file. External Lisp, okay, interactive, N ilp, v executing keyboard macro, non-interactive. Include Lisp.h. I don't know. I was expecting Emacs commands file to be to have more substance, but maybe it means the real action is elsewhere. Edit functions. I'm expecting this to be not so interesting, but I'm mildly curious. Okay, and in edit functions, we've got username, password, Lisp object tem, password entry for the current user. Set up system name even when dumping. Why? Go to car, point marker. Oh, point. Yeah, these are for Emacs. These are Emacs editing functions. So this is exciting. Car to string, byte to string. Should we look at point? Let's look at point. Defund point. Okay, so defund I guess is a macro that's going to defund is a C macro that's going to define, I'm guessing, a Lisp function with this stuff in it. It's going to take a point, an F point, an S point, some zero stuff. It's got a doc string, which is a comment. Are all the doc strings comments? How does this work? This is a C file. This seems like a valid C comment. But somehow, maybe when I don't know. Why isn't this a string literal? That I don't know. But I guess maybe when macro processing happens, something is done to it. And then it's going to be return void, I guess. And it's going to create a Lisp temp object. And we're going to call x set fast int temp pointer. Where did PT come from? And then we're going to return temp. Where did PT come from? Maybe it's just local to the file or the class. Let's see if we've got a PT in edit functions.h. Wait, there is no edit functions.h. Okay, well, whatever PT is, it's obviously point. Okay, so yeah, this is defining a bunch of the important edit functions. Line beginning position, POS EOL returns the position of the last character on the current line with argument n not nil or 1. Save excursion restore. These are things that I recognize from reading Emacs code. Save current buffer size. Okay, so that's where that stuff is. It's in edit functions, source/edit functions, edit funs.c. All right, eval. I think this was another file that has no header. We've got a v autoload queue. Non-nil means record all fsets and provides to be undone if the file is being autoloaded and not fully loaded. So we're gonna have some queue, v run hooks. This holds either the symbol run hooks or nil. It is nil at the early stage of startup and when Emacs is shutting down. V signaling function. Okay. Redisplay deep handler. We've got backtrace stuff. A fun call Lambda, which is going to, I assume, call a Lambda function. It's going to take a Lisp object as an argument. A pointer diff t, and a Lisp object pointer as a third argument. And it's going to return a Lisp object. And we can apply a Lambda, which is going to take two Lisp objects and a spectral ref and return our Lisp object. And we can, I guess, get the arity of a Lisp object. Presumably, yeah, okay. All right, great. Presumably a Lisp function, but I guess everything that's a Lisp object is also a function. Is that the base? I think that's how Lisp works, more or less. Okay. So a spectral symbol takes a union of a spec binding star PDL. Assert, I guess this is some kind of assertion. We're going to return PDL right arrow let dot symbol. Okay. So whatever spec binding is, it seems pretty important for the Lisp implementation. Here's init eval, which is going to be void. So eval is going to return nothing and take nothing. And we're going to get a spec PDL pointer. There's a dummy catcher at the top level, blah, blah, blah. I guess I can ignore that. vquit flag is set to q nil. Debug on xcall is 0. Lisp's eval depth is 0. When entered, debugger equals -1. And redisplay deep handler is null. Okay. And then I guess that inits eval, and then later I guess you're gonna do other stuff with eval. So you can restore stack limits, max ensure room, so like memory management stuff. Call debugger, we can call the debugger. Do debug on call. We can defun or. Eval args until one of them yields non-nil, then return that value. The remaining args are not evaluated at all. And then we can call and eval args until one of them yields nil, and then return nil. We can defun if. If condition yields non-nil, do then, else, do else. Okay. So these are basic things. Okay, here's prog_n. Eval body forms sequentially and return value of last one. Okay, so that's the way you like make a Lisp program. I'm not sure why these are in eval.c. So I was thinking initially when I clicked on this that eval was going to be part of a REPL that used other Lisp libraries, but I'm wondering if this eval is if it's doing all of the Lisp evaluation, not just when it's like running in a REPL kind of environment. We've got setQ, which is familiar from Emacs documentation. So set each sim to the value of its val. The symbols sims are variables. They are literal, not evaluated, because the values val are expressions. They are evaluated. Thus, setQ x 1 plus y sets x to the value quote 1 plus y end quote. The second val is not computed until after the first sim is set, and so on. Each val can use the new value of variable set earlier in the setQ. The return value of setQ form is the value of the last val. Okay. That's setQ. So it takes an fsetQ and ssetQ. 0. Maybe this is not what it takes. Maybe these are other bookkeeping about defuns. I'm not sure. We've got Lisp blah, blah, blah. It's going to take a Lisp object args, or it's going to return that. I'm not sure how to read this def fun macro syntax. Okay, and we've got a Lisp object val. It's going to be equal to args, and the tail is equal to args. For Emacs in nargs equals 0, we're going to loop const, I don't know, tail, I guess, while there exists a tail probably. And then we're going to increase args by 2. We're going to set sim to xcar of tail. Maybe that's the first character. Tail is going to be the x critter of tail, which I guess is the rest of the tail. And if I don't know what consp is, but if not consp tail, I guess if there's stuff left or whatever, x signal to wrong number of arguments. Okay, this object arg is going to be xcar tail, so that's going to be the argument. We're going to get the first thing, I think, and then the tail is going to be the second thing. And then we're going to eval sub on arg to get the value, but we're not going to eval sub on tail, I guess is the idea. And then we're going to call lex binding. Like for eval sub, we do not check declared special here since it's been done when let binding. So we're going to call lex. Then we're going to call symbol p on the symbol and whatever fast q is and some interpreter stuff. And I guess q nil if fast q doesn't like what it sees. And we're going to get a lex binding, which is a Lisp object. And then I guess check some error condition, whether it's lexically or dynamically bound. And then we're going to return val. All right. Let's set q. We can also quote function. Okay, there's a lot of cool stuff here. Let's see what else we got. Use frame.h. Yeah, so the frame, I guess, is the window that contains buffers. I'm going to move along pretty fast now because I've been at this for a while. I don't want these videos to get too long. All right, we've got scroll bars, condemned scroll bars. How do you condemn a scroll bar? The field is marked by the garbage collector. Maybe condemned means it's garbage collected. We can check whether we have window systems, tab bars, etc. Garbage. True if this frame should be fully redisplayed. Disables all optimizations by rebuilding matrices and redrawing. Okay, so that's windowing stuff. Frame.h. I think I just looked at, what was it? Oh, I opened frame.h twice. I'll ignore frame.c. Indent. We've got position. It has a buffer position, a byte position. They're both pointer diff t's. And hpos, vpos, I guess, horizontal and vertical positions. Previous hpos, I guess, so you can unwind stuff. And then I don't know what content is. You can compute motion, which returns a position. vMotion, I don't know. Skip invisible. The value of point when current column was called. And okay, some tab stuff. iTree. Tree and node structs are mainly here, so they can be allocated. In normal parent, left and right links found in binary trees. See also red below, which completes the red-black tree representation. Okay. So this is something related to the red-black trees. Let's see if iTree is something important in Emacs. We have tree sitter. Yeah, I don't know. Since this data structure will be used for overlays in an Emacs buffer, a second core operation is the ability to insert and delete gaps in the tree. So it's somehow used for overlays. Oh, we get a big comment in the C file, right? Intervals of the form begin end are stored as nodes. So, okay, so it's closed at begin and open at end are stored as nodes inside a RB tree, a red-black tree, ordered by begin. The core operation of this tree, besides insert, remove, etc., is finding all intervals intersecting with some given interval. So we're going to do, we've got a tree and we've got intervals, and we want to know when the intervals intersect. That's a standard, I guess, kind of way to perform interval intersection queries. In order to perform this operation efficiently, every node stores a third value called limit. And you can, oh, it's an interval tree. Yeah, okay. So this is an interval tree, and it's used for overlays. Sounds good. Okay, so key map. There's not a lot going on. Initial define Lispy key, which takes a Lisp object, a const char, and a const char. Get key map, current minor maps, key map m. Okay. So some key mappy stuff. Menu.h, I'm just going to ignore. This is going to be menu bar stuff. Profiler.c. I guess you would want to understand this if you wanted to understand Emacs performance, which I'm curious about, but I'm running long on time, so I'm going to ignore it for now. Scroll, I guess, is scroll functionality. I'll ignore that. And search and syntax and term. I'll take a quick look at thread. Okay, we've got BC thread state, bytecode interpreter thread state. Yeah. And it's got a stack and a stack end. It keeps track of the last thing searched. Catch list, handler list. Here's a spectral. Define spectral, current thread, m spectral. All right. Search regular expressions. Okay, so there's some non-trivial threading stuff. It's got a Lisp mutex. All right. Thread.c, I guess I don't really need to read the tree sitter stuff. And here's Lisp, which I should get to if I'm going to look at Emacs source code. Okay, so a lot of this stuff is going to be, it looks like implementations in Emacs Lisp of various modes and files like calc, calendar, cedit. We saw before what cedit was about. Emacs dash Lisp. I wonder if this is the mode or if this is the implementation. Maybe some of both. Advice, AVL tree, backquote, backtrace. EIEIO, I think we saw as part of cedit maybe. Helper, lisp.el. Let's look at, this might be Lisp mode. Radix tree, more trees. Syntax.el, I guess let's look at. And thunk. vtable. Yeah, let's look at vtable. All right, so Lisp editing commands for Emacs. So defun prompt regexp, forward SICP function. So I guess you go forward in S expression, backward S expression, forward list. And here we get maybe more about how the defuns work, because I assume this is more or less the same defun, but in Lisp version as opposed to the C macro. So we've got a defun backward Lisp, and it's going to take an optional arg interactive, a doc string essentially, and then here's the actual program. Uplist, downlist, uplist. I wonder if we have defun prog n. Yeah, okay. I thought we probably wouldn't, but I was just curious. Okay. We can mark defun. Okay, narrow to define. This is a lot of editing stuff, right? Is this all editing stuff? I think I just read a comment. Lisp editing commands. Yeah, cool. Syntax. So this is syntax table stuff, syntax properties function, commentary. The main exported function is syntax PSS. You might also need to call syntax PPSS flush cache. Okay, so this is syntax table. I'm guessing syntax highlighting stuff. Propertize whole lines. Yeah, all right. Thunk.el. Thunk provides functions and macros to delay the evaluation of forms. Use thunk delay to delay the evaluation of a form, requires lexical binding, and thunk force to evaluate it. The result of evaluation is cached and only happens once. Okay, that sounds good. Here's an example of a form for which evaluation is delayed. We're going to set queue delayed, thunk delay, message, this message is delayed. Delayed is not evaluated until thunk force is called. Like the following, thunk force delayed. So delayed is the name of the thing that we created, and it's created, I guess, using thunk delay. And thunk delay is undone by thunk force. So let's look at what thunk delay does. We're going to def macro thunk delay, and it's going to take, I guess, the rest, the body. I don't know if rest and body are both names, or if body is the rest of the stuff. Declare debug thing, do some CL assert. We're going to let forced, I don't know if forced is val lambda. So we're going to create it. Okay, yeah. So it's going to create a lambda of some type, and then, yeah, all right, that sounds right. And then thunk force is going to basically evaluate that lambda, which I assume is what thunk call does. Okay. What is vtable? Displaying data in tables. But this, I'm guessing this is not as related to C++. Okay, some sort of table stuff. All right, what else do we got? eShell as some shell thing, I think. News, which is, I think, the news reading stuff. Image, international language. This lime quail is internationalization stuff. Mail, MHE, I think, is some Emacs mode. Net, NXML is an XML mode, I think. Obsolete. Org mode is fun. At some point, I'll look at the org mode source code. Play, xterm, URL, use package, and VC. And then a bunch of changelog stuff. And then we've got some EL files that are kind of not in any directory. We've got abbrev, align, all out widgets, ANSI color, array, auth source, auto import, bookmark, buff menu, comment. Let's look at comment, I guess. Composite, some theme stuff, dframe. Let's look at dirred, D&D. Let's look at D&D, just in case it's Dungeons and Dragons related. Basis, find command, fold out, forms.el, frame, fringe, generic, help macro, Excel, ibuff. Do I want to look at iBuffer or iComplete? I guess I'll look at iBuffer. Info.el, jitlock. Is that jitterlock? Keymap.el. I guess I'll take a quick look at keymap. But these, I think, will be rather quick cursory looks. Reveal, registry, repeat, scroll lock, select, shell, simple, skeleton, so long, speedbar, SQLite. Didn't realize that was part of Emacs. I guess I'll have to try opening SQLite stuff in Emacs. Transient, tree widget, tree sitter, uniquify, wdirred, window, winner, woman, which I think is a version of man, like the Unix man command, and yank media. Okay, so let's take a couple of these. I'll look at keymap first because I'm a little bit nervous that it's going to be gigantic. Let's see how many lines of code keymap is. 650. Seen worse. All right, this library deals with the new keymap binding interface. The only key syntax allowed in these functions is the KBD one. Okay, so we can check keymap. We've got a defined function keymap set, I guess, which sets the keymap. Local set, global unset, keymap substitute, keymap set after, key parse, key valid, keymap lookup, and okay, we can def var keymap. Define variable name as a variable with a keymap definition. In addition to keywords accepted by defined keymap, this macro also accepts a doc keyword, which, if present, is used as the variable documentation string. All right. I wonder what how keymaps are actually stored. Maybe I assume they're stored in some sort of tree or hash. Oh, a card table, I guess. Yeah. Let's say that. All right. iBuffer is an advanced replacement for the buffer menu. So we'll just take a quick look here. We've got iBuffer formats, quantification, See that you can, I guess, syntax highlight stuff. This looks like a help thing. Directory abbreviation list. I guess it's mapping this to various functions like I does do query replace regexp. iBuffer visit buffer. All right. Cool. All right. What is D&D? Oh, drag and drop support. How do they do drag and drop support? So pure copy. Different protocols when a drop is made. The variable is used by D&D handle one URL. It contains regex and function pairs. It takes two arguments, URL, which is the URL dropped, and the action, which is the action to be performed on the drop. Okay. Handle mouse. When window P, position window position with selected window. When and D&D scroll margin, ignore errors. Okay. I'm kind of curious how they handle like window operations like this, but I think that would have to be for another time because that might be a whole rabbit hole. Because it's got to work, with the same Lisp code essentially on Mac and Windows and Linux with the different window managers. All right, so here we are in Dured. And we've got eval and compile stuff, subrx and clib. This was rewritten in 1990, 1991 to add tree features, file marking, and sorting. This is a major mode for directory browsing and editing. Okay. Listing switches, maybe use globstar. If non-nil, enable globstar if the shell supports it. Some shells enable this feature by default, for example, ZSH and Fish. Okay, Dured touch program. I guess that's where is the program touch located? Keep marker rename. Dured do what I mean target. Okay. Mouse drag files. If non-nil, allow the mouse to drag files from inside a Dured buffer. Dragging the mouse and then releasing it over the window of another program will result in that program opening or creating a copy of the file underneath the mouse pointer or all marked files if it was marked. Does that work? Can I just drag this over here? Wait, I'm in grep mode, so if I go, can I just like drag buffer.c? Not sure. I guess not. Maybe I don't have that enabled. All right. Dured before read and hook. Protocol, A-list, mark region. All right, Dured stuff, All right, comment, I guess, is, and comment stuff. I forget what comment even does. Is it completion? This file contains general command interpreter in a buffer package comment mode. The idea is that you can build specific process in a buffer modes on top of comment mode, e.g. Lisp, shell, scheme. Okay, so this is for implementing REPLs, essentially. Like I think you can implement like a Python interpreter based on comment. Okay, so prompt read only. If non-nil, the comment prompt is read only. You've got a prompt regular expression to recognize the prompts in the inferior process. You can highlight the prompt. You got some kill ring stuff. Scroll show maximum output. Password prompt. And somehow we're probably going to be replacing the password with, right, used to be for which fails to match non-English. It should like replace your password with like stars or whatever, right? Or not have any output. I don't know. Okay. EOL on send, term info stuff. Comment mode map is like a key map. Comment check proc. Comment exec, I guess execute. Okay, cool. Well, that's it for me in Emacs. There's a lot going on. It's got a fun and exciting storied history, and it's I guess fun to use. I don't know if it's fun to use, but it's a great editor. And at some point, I'll probably go back and look at individual pieces of Emacs. I'll look almost certainly at the org mode code because I know I use org mode for some stuff, and lots of people use org mode. I think org mode attracts a lot of people into Emacs for the first time, like especially non-programmers who want a really customizable like to-do list, kind of outlining organizational tool. I think Emacs org mode does that really well, and it's worth kind of giving it its own look, which is why I didn't look at any of the org mode code today. And that's all for me. Thanks for watching.